Hi to wow, or welcome to NASA Connect. I'm Jennifer Foley, and this is the National Museum of the American Indian.
And I'm Dr. Stan Odenwald at an archaeological site in Mexico. Hola! This is NASA Connect, the show that connects you to math, science, technology,
and NASA. On today's program, you will see how ancient cultures found a connection to the stars. You will also learn how many of these societies were very sophisticated when making celestial observations.
You'll also learn about the mathematics and geometry used by these ancient peoples to make their observations. What you will learn today will absolutely astound you. But first, Jennifer, tell us about that building that you're in.
Stan, this is the newest museum in our nation's capital. As you enter the museum, hundreds of written and spoken words meaning welcome in native languages throughout the Americas are projected onto this wall. These people, not only here in the Americas, but also their brothers and sisters in Africa, Asia, Europe, and the Pacific, looked at our starry skies. All of these people had a connection to the sun. In the museum, this room celebrates the sun. From this circle, the four cardinal directions, north, south, east, and west, extend out of the building. The angles of solstices and equinoxes are mapped on the floor. A light spectrum is cast by the sun, which shines through the prisms set into the south-facing wall. Each prism is sighted to the sun for a particular time of day and season. The dramatic designs in this modern museum show the connection between astronomy, nature, and people. That connection is the key to understanding how the ancients looked at our universe, which is the theme of today's program. Today, we will talk to Native American astronomers. Dr. Stan Odenwald will treat us to the foundations of astronomy as we know it today, and he will fill us in on the celestial accomplishments of the Mayans. Throughout the program, you will be asked to answer several inquiry-based questions. After the questions appear on the screen, your teacher will pause the program to allow you time to answer and discuss the questions. This is your time to explore and become critical thinkers. Now, let's learn more about ancient observatories. The science of interpreting the relationship between the sun and the daily lives of primitive people is called archaeoastronomy. Archaeo meaning archaeology, and astronomy meaning the study of stars. Observing celestial phenomena is the one constant that unifies humankind throughout space and time. Ancient man knew celestial events followed cycles, circles, and these events could be recorded. Approximately 5,000 years ago, they devised a way to place stones in certain positions to align for lunar and solar events. Events like seasons were noted and found to recur regularly with certain positions of the sun and stars.
The Earth spins on its axis once every day and gives us the familiar experience of daytime and nighttime. For thousands of years, humans have used this cosmic cycle to regulate their workday, their meals, and their sleep. The Earth orbits the sun once every year, and from this we get the familiar 365-day cycle. Earth's orbit around the sun is an ellipse. Basically, that means an oval, with the sun offset from the center of the ellipse. Does this mean that we have summer when the Earth is closest to the sun and winter when the Earth is farthest from the sun? The surprising fact is that the distance from the Earth to the sun has absolutely nothing to do with the changing seasons. Our northern hemisphere is closest to the sun in January and farthest from the sun in July. So what is causing the change in temperature? Earth's axis is tilted by 23.5 degrees from a line perpendicular to Earth's orbit. What does this mean? To understand this tilt, we have to use a bit of basic geometry. An angle has two sides and a vertex. The sides are rays that share a common endpoint called the vertex. The angle formed by two rays can be named in a variety of ways. For example, the angle formed by ray AB and ray AC can be named angle BAC, angle CAB, or angle A for short. Notice that A must be the middle letter in both three-letter names because it's the vertex. You can measure angles using a protractor. The unit of measure is degrees. Angles can be classified by their measures as acute, right, obtuse, and straight. If the Earth rotated on its axis perpendicular to or at a right angle to the orbit, there would be no changes in temperature. The Earth rotates at an angle 23.5 degrees from this perpendicular line. It's a very small tilt, but enough to affect the sun's rays hitting the Earth. This is a great time to pause the program and think about the following questions. Why is the area near Earth's equator hotter than the areas near the poles? If the tilt of Earth's axis measured 33 degrees rather than 23.5, how might seasonal changes and temperature ranges differ? Teachers, it's now time to pause the program. The tilt of the Earth's axis gives us our seasons, and because of the extremes in heat and cold, it's very important to keep track of the changing seasons if you're growing food. This seasonal cycle is important to ancient and even modern people. In some parts of the world, like the arid climates of the southwest states of the USA, the growing season was so short that people could not waste much time getting the seeds in the ground at the start of spring. But how do we predict when the growing season will begin in the spring? For that matter, how can we tell when the other seasons begin and end? It turns out that just by keeping track of how high up the sun gets over the horizon at noon, you can determine the start of the seasons exactly. Almost all ancient people that relied on planting times discovered this little relationship. The start of the 4 seasons, summer, fall, winter, and spring, are noted by what astronomers call the summer solstice, the fall equinox, the winter solstice, and the spring equinox. At the start of summer, around June 21st in the northern hemisphere, the sun is at its highest point above the horizon at noon. As the sun begins its movement back away from its maximum height, the number of daylight hours has declined to an equal number of daylight and nighttime hours. This is the fall equinox near September 21st. A few months later, the path of the sun arrives at its lowest point at noon. The sun spends very little time above the horizon of the northern hemisphere, and the night is much longer than day. Welcome to the winter solstice, or start of winter, around December 21st. After a few more months, the path of the sun works its way higher in the sky, eventually arriving at a path where day and night are equal. This happens March 21st at the spring equinox, a vital time for planting crops.